Okay, so problem 1.8 is just a few questions about rational and irrational numbers. So the first one, show with an example that the sum of two irrational numbers can be rational. Okay, so there are many ways to prove this because there are infinite examples, but one way to do it is, for instance, suppose x is 1 plus the square root of 2 and y is 1 minus the square root of 2. Okay, so x plus y will be 2. Okay, so it's 2, and then the irrational part cancels out. 2 is a rational number, and of course x and y are not rational because if you want their decimal expansion is 1 plus and then the decimal expansion of this square root of 2, which is infinite and not periodic. Okay, so it's these two guys are irrational, but their sum is rational. Okay, the same thing for the second question. So with an example that the product of two irrational numbers can be rational. This is even easier because, for instance, you have if x is square root of 2 and y is the square root of 2, then x times y is just 2, which is rational, and we know that square root of 2 is irrational again. Again, many different examples, and the final one is kind of the more interesting one in a sense. Is it possible to find irrational numbers x and y such that x to the y is a rational number? Okay, so this is kind of tricky, and yeah, I would encourage you to try and find these numbers by yourself before looking at the solution. Well, in general, try to solve these problems by yourself before looking at the solution, right? But so the way, or one example to do this is, okay, so if you think about this number, okay, a is the square root of 2 to the square root of 2 power. Okay, now if we exponentiate this number to the square root of 2, we have the square root of 2 to the square root of 2 to the square root of 2, and because of the rules of the exponentiation, these two numbers will be multiplied by each other, so we have 2, and so square root of 2 squared is just 2, okay, which is a rational number. Okay, so so you can tell me, oh well, but we don't know if a is actually a rational number. Is it a rational number? Sorry. Is it a rational number? Well, we don't know. Okay, there are many ways to prove this, but we won't go into them now. But so there are two possibilities. Either a is rational number. Okay. So if a is rational, then well, we have already proven this because x and y, in this case, x is equal to square root of 2, y equal to the square root of 2, x to the y, okay, x square root of 2 to the square root of 2 is a, which is a rational number. Okay, so this is the first possibility. So we have already proven this. But if a is not rational, okay, a doesn't belong to the rationals, then we know that a to the square root of 2 will be a rational number. So we just need to take x equal to a, y equal to the square root of 2. Okay, so this, it doesn't matter if a is rational or not. These combinations will work so that x to the y is a rational number. Okay.